In all of human history, we've glimpsed only a tiny handful of visitors from outside our solar system. True cosmic wanderers journeying from distant unknown stars. Imagine spotting an object speeding through our solar neighbourhood, a mysterious traveller that came from an alien planetary system and won't ever return. This isn't a science fiction tale. This is the reality of Comet 3I/ATLAS. Welcome to the sleepy cosmos, where we gently unlock the universe's most fascinating secrets. Tonight, we're diving deep into the captivating story of Comet 3I/ATLAS, one of only 3 interstellar objects humanity has ever witnessed. Unlike typical comets that endlessly loop around our Sun, 3I/ATLAS is special. It arrived swiftly, is leaving rapidly, and will never come back. Its hyperbolic trajectory means it's not tied to our Sun's gravity, marking it as a fleeting visitor from the stars. First discovered in 2023 by the powerful ATLAS telescope network designed to spot near-Earth objects, this comet immediately stood out. Scientists quickly recognized they had uncovered something extraordinary, an object forged around another star, ejected into space possibly millions of years ago by dramatic cosmic events. Perhaps a massive planet flung it outward, or maybe it escaped during the chaotic collapse of its original stellar system. Whatever its origin, Comet 3I/ATLAS has travelled unimaginable distances to briefly shine near our Sun, offering us a rare glimpse into interstellar mysteries. In this episode, we'll gently yet compellingly guide you through the incredible story of 3I/ATLAS, its dramatic discovery, how astronomers confirmed its interstellar origins, and what this rare cosmic traveller can teach us about the universe. No heavy jargon or complicated mathematics here. Just clear, calming insights as if we're sharing stories under the stars. Whether you're settling into bed, unwinding on your couch, or simply looking for a relaxing end to your day, you're in the right place. Feel free to drift off as we explore together. There's no pressure to stay awake. Just relax, breathe slowly, and let your imagination follow the quiet voyage of this extraordinary comet from beyond our solar system. If our peaceful voyages through the cosmos brings comfort to your evening, please consider giving this video a gentle thumbs up and subscribing. It's completely free and helps this little celestial journey continue. Now let's begin this tranquil adventure, exploring how scientists detect distant cosmic travelers, the amazing mechanics of gravitational slingshots, and why objects like 3I/ATLAS have become so intriguing. These aren't just fascinating facts, they offer profound insights into planetary formation, the evolution of solar systems, and the intricate cosmic dance of gravity, dust, and time. So, as you ease into relaxation, let your thoughts float effortlessly alongside Comet 3I/TLAS, wandering gently through the cosmos. Imagine you're drifting through space. You've left behind the warm glow of Earth. You've passed the silent orbits of Mars and Jupiter. The Sun is now just a pale beacon in the distance, its rays growing faint. As you float farther, the solar system begins to thin. Fewer planets, less light, more darkness. Out here, we enter what astronomers call interstellar space, the vast, cold region that stretches between stars. It's a place few human-made objects have ever touched. In fact, only 2 probes, Voyager 1 and Voyager 2, have crossed the boundary, each continuing its journey into the unknown with whispers of data sent home. And then something remarkable happens. From the darkness, a stranger appears. It's not from any place we know. Not from Mars, not from the asteroid belt, not from the icy fringes of the Kuiper belt, or even the more distant Oort cloud. It comes from beyond, from another star, perhaps another time. A fragment of some long-forgotten place drifting quietly into our neighbourhood. Astronomers call it 3I/ATLAS. That name might sound technical, but it carries a story. The 3I means it's the third object ever detected coming into our solar system from interstellar space. Before it, there was Oumuamua in 2017, long and cigar-shaped, and Borisov in 2019, an icy active comet. And now, in 2025, we have ATLAS, our third visitor from the stars. But what does it mean to be interstellar? Let's gently unfold that idea. Most objects we see in the night sky, the moon, the planets, even the stars, are part of our own galaxy. The solar system, where we live, is like a tiny island orbiting our sun. Planets, moons, asteroids and comets, all of them belong to the sun's gravitational family. Even the icy visitors from the far reaches of the Oort cloud are technically still part of this system. But an interstellar object is different. It doesn't orbit our sun. In fact, it doesn't belong here at all. It's just passing through. These objects travel on something called a hyperbolic orbit. That means they aren't looping around the sun like the planets do. Instead, they follow a path more like a curve or a swooping arc, one that allows them to enter the solar system, pass by the sun once, and then leave forever. Unless something drastically changes their path, they will never return. Think of it like tossing a pebble into a stream. The pebble enters the water, drifts along with the current for a moment, and then continues downstream, never to return to the same spot again. 3I/ATLAS is just such a pebble. It entered the solar system from the direction of the constellation Sagittarius, a dense and brilliant patch of the sky near the centre of our galaxy. From that direction, it quietly made its approach, far from the gaze of our usual telescopes, until, on a chilly July night, it was finally spotted. The telescope that discovered it is part of the ATLAS project, short for Asteroid Terrestrial Impact Last Alert System. It's a network of telescopes designed to scan the skies for moving objects, especially ones that might be coming uncomfortably close to Earth. Atlas is based in places like Hawaii, Chile and South Africa, locations chosen to give the clearest views of the night sky from different parts of the globe. These telescopes take hundreds of images each night, comparing them to spot tiny movements, the telltale sign of something new crossing the stars. On July 1st, 2025, one of these telescopes perched in the Chilean Andes noticed something strange. A faint object was gliding across the galactic plane, the flat glowing disk of our Milky Way. The object was unlike the usual suspects. It was fast, it was faint, and it was coming from a peculiar direction. At first it was labelled with a temporary name, 11PL3Z, more a catalogue number than a name. But as astronomers looked closer, using data from previous nights and other observatories, a pattern began to emerge. This object had been seen before, not just by Atlas, but by the Zwicky Transient Facility in California and other telescopes. These earlier unnoticed images were called prediscovery observations. With this data stitched together, a clear path began to form, and that path wasn't circular, it wasn't elliptical, it was hyperbolic. That told astronomers everything they needed to know. This object didn't come from our solar system. It came from somewhere else entirely. With that revelation, the object earned its proper name, 3I/ATLAS. The 3 marks it as the third interstellar object. The I stands for interstellar, and Atlas, of course, honours the telescope that first saw it. It's poetic in a way. Atlas, in mythology, was the titan who held up the heavens. Now the telescope named after him scans those same heavens and has found something truly cosmic. So now we know it's interstellar, we know it's fast, and we know it doesn't belong to our sun's family of objects. But what else can it tell us? That's what astronomers are hoping to find out, and what we'll begin to explore in the next section. But how do we even recognize an interstellar object when we see one? Most objects we study are gravitationally bound to the sun. They follow looping paths, curving back around in predictable rhythms. But an interstellar object breaks that mold. Its motion is hyperbolic, open-ended, shaped more like a swooping arc than a circle. It enters the solar system only once, passing close to the sun, then continuing out into the void, never to return. The discovery of 3I/ATLAS is also a reminder of how vast space truly is. To travel between stars requires surviving distances so enormous they're hard to picture. A grain of rock like 3I/ATLAS may have wandered through space for millions or billions of years before reaching us. It is ancient, perhaps older than our Sun, and carries in its makeup the secrets of long-lost regions of the galaxy. And yet we almost didn't see it. The region it came from, towards Sagittarius, is packed with stars and light, making it hard to detect faint newcomers. But the Atlas telescope's wide field of view and nightly sky scans helped it catch this faint, fast traveller. Without it, 3I/ATLAS might have slipped by unnoticed, lost to the darkness forever. As 3I/ATLAS approached, astronomers asked new questions. Is it icy or rocky? Is it active like a comet, or inert like an asteroid? Where might it have come from? Each of these questions leads to more, and every observation brings us a bit closer to understanding this visitor from the stars. And now here it is, sailing through our skies, bright enough to be tracked and studied. It won't linger. It will pass near the sun and then drift away once more. But for this brief moment, it is here, and in this window of time we can look at it, wonder about it, and learn what we can. These glimpses remind us of how much there still is to discover in the universe. Even now, as you listen, the comet is still moving, gliding silently through the inner solar system. Somewhere above you, it carries with it the ancient dust of another star, another time. It reminds us how little we truly know. How many other travellers may pass unseen through the dark, and how rare and precious it is to catch one, just once, in our brief moment of awareness. Let's go back to the moment when it all began. It was a cool July evening in 2025, and the skies above the southern hemisphere were clear. At an observatory in Rio Hurtado, Chile, one of the telescopes belonging to the ATLAS network quietly scanned the heavens. Its nightly task is both humble and heroic. To take image after image of the night sky, searching for movement. A flicker here, a shift there, and suddenly something new is revealed. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. As the name suggests, its original mission was to detect space rocks that could potentially come too close to Earth. It's like a celestial early warning system, designed to spot hazardous objects before they get too near. But over the years, Atlas has proven useful for far more than just asteroid defense. The project includes 4 main telescopes, located in Hawaii, Chile, and South Africa. This global positioning allows Atlas to keep watch over much of the sky at any given time. Each night these telescopes take hundreds of short exposure images, scanning for the tiniest signs of motion against the backdrop of fixed stars. On that particular night in early July, the telescope in Chile captured something unusual. Among the countless pinpricks of light was a faint, fast-moving blur, barely visible and easily mistaken for noise. But the system flagged it. 4 images, each 30 seconds apart, showed that something was indeed moving. The trajectory pointed inwards toward the solar system. That was enough to catch the attention of astronomers monitoring the data. At first, the object was simply labelled A11PL3Z, a placeholder name, like a license plate for a car whose origin is still unknown. Soon, the Minor Planet Center, the organization responsible for tracking objects in our solar system, issued an alert. Other observatories were asked to contribute their own images in hopes of triangulating the object's path. As data began to pour in, something curious happened. Astronomers realized this object had already been seen before. Other Atlas telescopes, as well as the Zwicky Transient Facility in California, had captured it in previous weeks. They just hadn't recognized it yet. These early sightings are known as pre-discovery observations, and they're like finding older photos of a person you just met. Suddenly, the timeline expands and a fuller picture begins to form. With more data points to work with, scientists could now calculate the object's trajectory, and what they found was startling. The orbit wasn't circular, it wasn't elliptical either. Instead, it was something else entirely: hyperbolic. We talked a bit about hyperbolic orbits before, but here's a gentle recap. A circular orbit is a perfect loop. An elliptical orbit is more like an oval. It brings objects closer to the Sun at one end and farther away at the other, but still keeps them bound by the Sun's gravity. Hyperbolic orbits, however, are open-ended. They don't loop. They swing by the Sun once, then curve outward again, escaping into space never to return. And this object, now dubbed 3I/ATLAS, had an extreme hyperbolic orbit, more exaggerated than almost any we've seen. Its eccentricity, the measure of how stretched or non-circular its path is, was around 6. Most comets in our solar system have eccentricities below that, but 3I/ATLAS, it was far beyond. This told astronomers one very important thing. This object came from outside the solar system, an interstellar origin. Once that realization set in, the excitement grew. Interstellar objects are vanishingly rare. Before 2017, we hadn't seen any at all. Then came Oumuamua, then Borisov in 2019, and now, in 2025, Atlas had spotted the third. It wasn't just the shape of the orbit that told astronomers this object was special. Its speed was also remarkable. At the time of detection, 3I/ATLAS was moving about 58 kilometers per second. That's fast. Much faster than most objects we regularly track. For comparison, Earth orbits the Sun at about 30 kilometers per second. Oumuamua moved at about 26 kilometers per second, and Borisov around 32 kilometers per second. So Atlas was zipping along at nearly double their pace. That velocity, combined with the hyperbolic trajectory, sealed its fate as a visitor from beyond. But how do we know what an object is just by looking at a few specks of light? It takes careful analysis. Astronomers examine not just where the object is, but how it moves across the sky over time. By tracking its position in multiple images, they can build a curve, a map of motion. This curve, when compared to known models of orbital dynamics, tells us how the object is behaving gravitationally. From there, scientists infer its orbit, its velocity, and even its likely origin. Of course, all of this depends on the quality and quantity of data. That's why pre-discovery observations are so valuable. Every extra point along the object's path reduces uncertainty. and with 3I/ATLAS, there were enough images from ATLAS, Zwicky and others to build a robust model. Still, questions remained. What kind of object was it? A rocky asteroid? An icy comet? Something in between? To answer that, astronomers look for signs of activity, specifically whether the object had a coma. A coma is a fuzzy halo of gas and dust that forms around a comet's nucleus when it gets close enough to the Sun. Heat causes frozen materials to vaporize, releasing particles into space. These particles reflect sunlight and create the characteristic glow of a comet, and in 3I/ATLAS, that coma was there, faint but present. Its official designation became C/2025 N1ATLAS, where C stands for comet, 2025 is the year of discovery, N refers to the half-month of the sighting, and 1 indicates it was the first object of its kind found in that period. But to most people it remained simply 3I/ATLAS, the third interstellar object known to science. Even with all this data, there's still so much to learn. How big is it? What's it made of? Where did it come from? As new observations come in, we'll continue to fill in the blanks. But for now we know this. A stranger has entered our solar system. Spotted by careful eyes in the mountains of Chile, flagged by a network of global observatories, and recognized by the shape of its flight. It is not from here, and soon it will be gone again. But while it's here, it gives us a glimpse of the greater galaxy beyond, and that perhaps is the real gift of discovery. Interestingly, part of what made 3I/ATLAS hard to spot was the direction it came from. It approached from the Sagittarius constellation, a crowded part of the sky near the galaxy's centre. This region is bright and busy, making it challenging for telescopes to pick out faint moving dots. Many surveys avoid it, but Atlas, with its specialised design, was able to catch what others missed. This ability sets ATLAS apart from many other sky surveys. Projects like Pan-STARRS and Catalina tend to focus on darker areas, avoiding the galaxy's bright plane. Atlas, however, is built to handle these conditions, offering a broader view and better sensitivity in complex sky regions. And discoveries like 3I/ATLAS reshape how we see the universe. Each interstellar visitor is more than a frozen relic. It's a messenger from a distant star. These objects hold hints about how other systems form and what materials drift between the stars. Now that we've seen how 3I/ATLAS was discovered, let's take a closer look at what this object actually is. At first glance, it behaves like a comet. It has a visible coma, the soft halo of gas and dust that forms when sunlight warms the frozen nucleus and causes it to release material. This outgassing is what gives comets their characteristic glow, and in the case of 3I/ATLAS, that faint shimmer was our first clue. Comets are essentially icy time capsules. They're made of ancient material, frozen gases, dust, and rock, left over from the formation of planetary systems. Most comets in our solar system originate from two distant regions, the Kuiper belt, which lies just beyond Neptune, and the even farther Oort cloud, a spherical shell of icy bodies that surrounds the solar system like a vast halo. 3I/ATLAS doesn't come from either of those places. It comes from beyond. Its hyperbolic orbit and extreme speed, 58 kilometers per second, confirm that it is not gravitationally bound to the Sun, it's just passing through. That makes it an interstellar comet, a kind of celestial tourist from another star system. But where exactly did it come from? That's a more difficult question, We can estimate the direction it came from, the constellation Sagittarius near the centre of the Milky Way, but pinning down its exact origin is nearly impossible. The galaxy is dynamic, stars move, gravitational forces shift trajectories. After a journey that may have lasted billions of years, it's hard to trace a straight line back to any single point. Even so, its characteristics tell us little about its past. First, its brightness. 3. I-Atlas is the brightest interstellar object we've observed so far. When first spotted, it had a visual magnitude around 17.8, faint to the naked eye, but quite noticeable for professional telescopes. That brightness increased rapidly in the weeks following its discovery. Second, its size. Based on its reflectivity or albedo, astronomers estimate its nucleus to be about 10 kilometers wide. That's large for a comet. It's much bigger than Oumuamua, which was only a few hundred meters long, and even bigger than Borisov, which was estimated to be around 1 to 2 kilometers in diameter. This makes 3 IATLAS an unusually large interstellar visitor, and size matters when studying comets. Larger comets retain heat longer and release more material. They can also survive closer approaches to the Sun without breaking apart. The fact that 3I/ATLAS is holding together well so far is promising. It means we may get months of observations before it slips away. But what is it made of? That's the real mystery. Most comets contain a mix of water ice, carbon compounds, silicates, and metals. As they near the Sun, these materials heat up and create visible activity, comas, tails, and sometimes even outbursts. 3I/ATLAS has shown signs of this behaviour, but only faintly. Its coma is small. Its tail, though present, is short, spanning just a few arc-seconds in most images. It's easy to miss unless you know what to look for. But it's there, trailing behind the nucleus like a whisper. Some astronomers suggest that 3I/ATLAS might be made of denser material, or that it has a relatively inactive surface. Others propose that the comet simply hasn't been close enough to the Sun yet to trigger full-scale activity. It's also possible that the object has a low dust-to-gas ratio, meaning it releases more gas than solid particles when heated. That could explain the faint coma and tail. In any case, further observation will help clarify what's going on beneath the surface. To study these features, astronomers use light curves, graphs of brightness over time. As the comet rotates, different parts of its surface face the Earth, reflecting varying amounts of sunlight. By tracking these changes, scientists can estimate its rotation period. With 3I/ATLAS, astronomers have detected a roughly 29-hour rotation cycle. That means the comet spins on its axis just a little slower than Earth does. Interestingly, the brightness variation is very small, only about 0.2 magnitudes, suggesting the comet is either nearly spherical or its surface has few highly reflective features. This gentle rotation adds to the calm, steady nature of the object. Nothing about 3I/ATLAS appears chaotic or tumbling. It's just drifting through, turning slowly, glowing faintly, and reminding us how serene the cosmos can be. But not everyone sees it that way. Some researchers, including Harvard's Avi Loeb, have raised more speculative possibilities. They note that 3I/ATLAS entered the solar system on a very specific trajectory, one that aligns almost perfectly with the ecliptic, the plane in which the planets orbit. That's unusual. Most interstellar objects enter at random angles. This one came in flat like a stone skipping across a pond. Loeb and others have suggested that such a path could be intentional. perhaps chosen to maximize planetary flybys or to avoid detection by Earth. They also note that 3I/ATLAS passed unusually close to Venus, Mars and Jupiter, a sequence that, while statistically possible, is extremely rare. It's important to approach such ideas with caution. There's no solid evidence that 3I/ATLAS is anything other than natural, but in science, strange patterns invite careful examination, and if we've learned anything from past discoveries, it's that the universe is full of surprises. Whatever its origin, 3I/ATLAS gives us a chance to study a fragment of another world, a frozen ember from a star system we may never find, a relic from before the sun was born, and while it doesn't flash brightly or behave dramatically, its quiet passage through our skies is no less profound. In time, we'll know more. As it moves closest to the sun, we'll watch for changes, bursts of gas, shifting light, new structures in its tail. We'll study its spectrum, searching for chemical fingerprints, and we'll compare it with other interstellar objects to see what makes it similar and what makes it unique. For now, though, we watch, we wait, and we wonder. Because sometimes the most extraordinary stories are told in whispers, not shouts. 3I/ATLAS is whispering now, across the vacuum of space, and we're lucky enough to hear it. One reason astronomers are so fascinated by 3I/ATLAS is because each interstellar object acts as a kind of time traveller. They may have formed in the earliest days of their home systems. When one arrives in our part of space, it brings a piece of that ancient past with it. For scientists, that's like getting a sample from another star's nursery. Instead of waiting for distant signals, we get to examine a real object, a frozen relic of another system's birth. There's also the question of colour, a small but telling detail. 3I/ATLAS appears slightly redder than the Sun, a trait shared with other distant, aged bodies. This suggests exposure to cosmic radiation and the presence of organic materials on its surface. In one observation, a faint water ice signature was detected. Yet, when analysed closely, the spectral profile didn't align with what's typical for water. Some features were missing, others unexpected, making the analysis a bit puzzling and all the more intriguing. At first glance, 3I/ATLAS might look like just another faint comet in the night sky. But the more astronomers study it, the more unusual it appears. Beneath its quiet exterior, that interstellar visitor holds a number of mysteries, some subtle, some extraordinary. Let's begin with the orbit. Most objects from outside our solar system approach from odd angles. They come in tilted, diving through our planetary plane and then exiting again into the void. But 3I/ATLAS is different. Its trajectory lies almost perfectly in the ecliptic, the flat plane in which the planets orbit the Sun. That kind of alignment is rare, very rare. The odds of a random interstellar object entering our system on such a perfectly planar path are incredibly low, estimated by some at just 0.2%. It's like tossing a pebble into a spinning coin and having it land precisely in the groove. Why does that matter? Because a flat trajectory brings 3I/ATLAS unusually close to several of the inner planets. It passed near Venus, then near Mars, then near Jupiter, 3 planetary flybys in a single loop. That sequence alone is strange. The chances of this pattern occurring by coincidence are estimated to be just 0.005%. To some, this has raised eyebrows. If you are planning a spacecraft mission to explore our solar system, this is the kind of path you might choose. One that uses gravity from multiple planets, one that moves along the most efficient, least disruptive route. It resembles what we call a gravity assist trajectory, where a spacecraft uses the motion of a planet to alter its speed and direction. Could 3I/ATLAS be something more than a comet? Most scientists say no, but it's still a question worth exploring, if only to better understand the possibilities. These patterns alone don't prove anything artificial. Nature is full of strange coincidences, but strange coincidences often lead to deeper discoveries. Another oddity, its timing. 3I/ATLAS reaches its closest approach to the Sun, its perihelion on October 30th. That moment curiously happens while the object is on the far side of the Sun, completely obscured from Earth's view. That in itself isn't unheard of, but it's another layer of mystery. We won't be able to observe the comet during its perihelion. The Sun will block our line of sight. So the most active phase, when solar heat may cause outbursts, tail formation, or structural changes, will happen behind a curtain. It's almost like it's hiding. Again, probably a coincidence, but it adds to the sense that 3I/ATLAS is not quite like other comets. When it comes back into view in early December, it will already be on its way out of the solar system. Whatever transformations it undergoes during its solar encounter will be over. We'll only see the aftermath, like trying to guess what happened during a storm by looking at the branches afterward. So, what can we learn from what we can see? Even from afar, astronomers have measured 31/ATLAS's tail, a faint streak of dust and gas trailing behind it. Early estimates placed its length at only a few arc-seconds, but newer observations suggest it may stretch over 25,000 kilometers, a thread of stardust across the black. But despite its growing brightness and modest activity, it's still not behaving exactly like a typical comet. In fact, some astronomers are puzzled by how little outgassing is occurring. Comets heat up and vent material, sometimes violently, when they near the Sun. But 3I/ATLAS has remained surprisingly calm. Some suggest it's simply a slow starter. Others think it may have already lost much of its volatile material during its journey through interstellar space. It could also mean the surface is coated with dust or rock, insulating the ice beneath, like a blanket holding in the cold, preventing it from responding to the Sun's heat. Or maybe it's just a quiet traveller by nature. All of these questions speak to one thing: how little we know. Interstellar visitors are rare. Each one teaches us something new, not only about itself but about the broader universe. If 3I/ATLAS doesn't behave like Borisov and doesn't behave like Oumuamua, then maybe there's a third category we haven't defined yet. Maybe these are not exceptions, but clues to a larger story. To uncover that story, astronomers use every tool available. Spectroscopy helps identify what elements are present. Photometry tracks brightness and changes. Ground-based telescopes watch for motion. Space-based observatories monitor light curves and tail structures. Citizen scientists even contribute images and data to collaborative platforms like the Astronomer's Telegram. The more eyes, the more data. The more data, the clearer the picture. In fact, one of the reasons we know so much about 3I/ATLAS's path and brightness is because of this global collaboration. Amateurs with modest equipment can contribute meaningful observations, especially when professional telescopes are pointed elsewhere. And when you combine that community effort with advanced orbital modelling, you get something powerful. A story written in starlight. A story that stretches across systems and centuries. There's also a poetic side to all of this. The idea that a frozen rock, older than our planet, could drift through space for billions of years. only to be spotted by a telescope in Chile one quiet night. That it could light up briefly as it passes near our sun, then vanish again into darkness. It's like catching a fallen star, except the fall takes eons. So what makes 3I/ATLAS special? Is it the orbit, the speed, the shape of the tail, the eerie quietness? Yes, all of it. But it's also the questions it raises. Questions about origins, about time, about how much we've yet to learn. Every new object challenges our assumptions, and this one, with its silence and subtlety, does it in a whisper. In a universe full of noise, 3I/ATLAS is a soft voice, one that urges us to listen more closely, to wonder more deeply, and to stay open to surprises, even quiet ones. And maybe, just maybe, it's reminding us that the cosmos doesn't always shout. Sometimes it speaks in hushes, in glimpses, in the faint shimmer of a tail across the sky. And when it does, we must be still enough to notice. One of the things that makes 3I/ATLAS especially valuable is that we can observe it while it's still inbound, before its closest approach to the sun. That wasn't the case with Oumuamua. By the time we realised it was interstellar, it was already leaving. We missed the window, but with 3I/ATLAS, we have time to prepare, to study, to listen. Astronomers have already scheduled intensive observation campaigns. Instruments around the world are watching, from large research observatories to amateur backyard setups. Some are measuring brightness curves. Others are capturing spectra, hoping to decode the elements hiding in its faint light. It's a rare opportunity to see an alien object in real time, a cosmic guest that came to us, and what might it teach us? Comets in our solar system have helped scientists learn about the early Earth, about water, about organics, even about the seeds of life. If interstellar comets carry similar materials, it could mean these ingredients are common, scattered among the stars, not unique to our sun's neighbourhood. That possibility ties into the larger question: how common is life in the universe? If comets like 3I/ATLAS carry organic molecules, even in trace amounts, it might hint at a shared chemistry between distant star systems. Perhaps life's ingredients are everywhere, waiting for the right conditions. Or perhaps they're rare, and these glimpses are precious for that very reason. Even in the calm, measured world of astronomy, there are moments when mystery stirs the imagination. 3I/ATLAS is one of those moments. With its graceful path, soft brightness, and quiet behaviour, the comet has ignited more than just scientific curiosity. It has also sparked speculation, some grounded in data, others drifting into the realms of possibility. Let's start with what we know. 3I/ATLAS has a hyperbolic orbit, indicating that it came from beyond the solar system. Its speed, angle of entry, and faint tail all suggest it's a comet, likely icy in composition and only mildly active. It's large too, about 10 kilometers in diameter, making it bigger than the other interstellar visitors we've seen. So far, so solid. But then there are the anomalies. For instance, 3I/ATLAS arrived along a very flat trajectory, almost perfectly aligned with the ecliptic plane. This is the invisible disk in which most planets orbit the Sun. It's like the tabletop on which the solar system is arranged. Interstellar objects typically arrive at odd angles, slicing through this plane in steep arcs, but 3I/ATLAS came in almost edge-on. That by itself is unusual, but paired with its planetary flybys, Venus, Mars, Jupiter, and its perihelion timing behind the Sun, the object begins to look even more curious. Some scientists, like Professor Avi Loeb from Harvard, have suggested we shouldn't rule out the possibility that 3I/ATLAS is more than it seems. Loeb is known for his controversial hypothesis about Oumuamua, the first interstellar object ever observed. When Oumuamua showed unexplained acceleration and no visible tail, Loeb proposed it might be artificial, perhaps a piece of alien technology, such as a light sail or probe. Most of the scientific community disagreed, but his views ignited public interest and reopened conversations about how we interpret rare cosmic events. Now, with 3I/ATLAS, Loeb and others are again asking provocative questions. Could this object be behaving the way it does because it's engineered to do so? Could its path through the planetary plane and its avoidance of Earth's line of sight during perihelion be intentional, not random? Again, most astronomers remain skeptical. The standard explanation is that natural processes can produce surprising results. The laws of probability allow for rare alignments, even if they're uncommon, and with so few interstellar objects on record, we don't yet know how strange normal really is. But even within standard science, 3I/ATLAS is prompting thoughtful questions. One of those questions is about composition. Why is the comet so faintly active? Why does its coma remain small and its tail so subtle despite its size? Some theories suggest that 3I/ATLAS may be coated in a dense crusty surface that insulates its inner ice. Others think it may have already lost its most volatile materials during its long interstellar journey. If that's the case, we may be seeing a fossilized core, a comet that burned brightly billions of years ago and is now coasting quietly through space. Another angle of speculation comes from its spectrum. Early spectral readings hinted at the presence of water ice, a typical cometary component. But the detailed patterns didn't match perfectly. Certain wavelengths behaved differently than expected. Peaks appeared where there should have been valleys, and vice versa. That doesn't mean the object is artificial, but it does suggest we're dealing with unfamiliar chemistry, or perhaps optical effects we don't yet understand. The same was true for Oumuamua. Its reflectivity, spin, and shape all defied expectations. In that case, the debate still continues. Was it a flat, tumbling rock, a porous shard of nitrogen ice, or something else entirely? And here we are again. Another object, another question mark. What's different this time is that we have more time. 3I/ATLAS was detected months before its closest approach. That gives scientists an opportunity to plan observations, to test hypotheses, and to learn from the gaps we encountered during previous interstellar encounters. One thing many researchers agree on: we need better protocols for responding to interstellar visitors. Imagine if we'd been able to send a small probe toward Oumuamua. Imagine catching up with 3I/ATLAS before it leaves. These are technically challenging missions, but not impossible, and the scientific rewards could be immense. That's why missions like ESA's Comet Interceptor, designed to launch and then wait in space for a target, are gaining momentum. With the right timing, a mission like that could rendezvous with a newly discovered object, collecting data as it flies past. In the meantime, telescopes will do their part. Even Earth-based observers can contribute, tracking brightness, capturing motion, looking for unexpected activity. Some researchers are even modelling the gravitational interactions between 3I/ATLAS and the planets it passes, searching for signs of deflection, outgassing, or rotation shifts. So far, 3I/ATLAS has remained remarkably consistent. No wild flares, no sudden changes, just a steady presence, glowing faintly, whispering questions as it moves. And then, of course, there are the deeper speculations. Some theorists point to the dark forest hypothesis, a perspective drawn from science fiction, but not entirely out of bounds. It suggests that intelligent civilizations might choose to hide, to observe silently, rather than risk exposure. In such a universe, a probe disguised as a comet would be a reasonable strategy. It's not a mainstream idea, but it's one that resonates in certain corners of the scientific imagination, because ultimately speculation serves a purpose. It invites us to think creatively, to imagine possibilities, and then look for ways to test them. It doesn't mean we abandon scientific rigor. It means we stay open to questions, open to wonder, open to the fact that we still know so little about what lies beyond our solar system. Every interstellar visitor is a reminder of that. They are messengers from faraway places, shaped by physics we know and histories we don't. They've crossed immense distances, not because they were sent, but because the cosmos is vast and full of motion. Most are probably natural, but even if they are no less extraordinary. So what is 3I/ATLAS? A quiet comet, shaped by time and distance. An icy relic whispering secrets in a language of dust, or something we haven't thought of yet. The beauty of science is that it doesn't rush to answer. It listens, it observes, it asks, and then it asks again. As 3I/ATLAS continues its journey, we'll keep asking, and maybe, just maybe, it will answer back. And then there's the question of age. Some estimates suggest that 3I/ATLAS could be more than 7 billion years old, older than our Sun, older than Earth, older than many of the stars in our local neighbourhood. If that's true, it means we're looking at something ancient beyond comprehension, formed before our solar system even existed. That age isn't based on guesswork alone. Astronomers sometimes infer an object's age from its velocity. In general, older objects tend to travel faster due to repeated gravitational encounters over time. 3I/ATLAS, moving at 58 kilometers per second, fits into that pattern. It may have been flung from its home star billions of years ago, only now arriving at our doorstep. Its long journey might also explain why it seems quiet. Billions of years in the interstellar medium, a harsh environment filled with radiation and dust, could erode a comet's outer layers. Volatile gases might have escaped long ago. What remains is a hardened shell, like the petrified remains of a once active traveller, now reduced to a soft glow and a silent trail. And still, it draws us in. Even without flashing lights or sudden drama, it captures the imagination. Because deep down, we understand what it represents. A connection to something beyond. A bridge between stars. A small, icy ambassador from the unknown sailing silently past our little world. In a universe so vast it's easy to feel small. The stars stretch on forever. The galaxies swirl in endless spirals, and the distances between them are almost beyond imagination. Yet every so often something reaches across that immense void and brushes past our corner of the cosmos. 3I/ATLAS is one of those somethings. But why does it matter? Why should a faint icy object passing quietly through the solar system draw our attention? What makes this interstellar visitor more than just a curiosity? To answer that, we need to step back and look at the bigger picture. For most of human history, we believed our solar system was the centre of everything. Then we learned that we orbit the Sun. Later, we discovered that the Sun is just one star among billions in the Milky Way. And now, we know that even our galaxy is just one among trillions. Each step has pushed us farther from the centre and closer to a new kind of understanding, one that tells us we're part of something immense and interconnected. 3. I/ATLAS is a tangible reminder of that connection. It is a visitor from another star, not imagined in science fiction, but observed through telescopes and measured with instruments. It's real, it exists, and it came here. That alone is extraordinary, because it means the space between stars isn't empty. It's filled with debris, fragments, travellers. Some are ancient, some are new. Some, like 3I/ATLAS, carry stories we haven't yet deciphered. By studying this comet, we gain insight into places we may never visit. Its materials, its orbit, its behaviour, all of these are clues about how other planetary systems form, evolve, and decay. It's a piece of another puzzle drifting into ours. And even if 3I/ATLAS is entirely natural, which it likely is, it still has the power to change how we think. It challenges assumptions. It asks us to refine our models. It reminds us that science is not just about facts, but about curiosity, the kind that peers into the dark and wonders what might be there. When we observe an interstellar object, we're not just collecting data. We're witnessing a moment of cosmic intersection, a rare overlap of timelines where something from out there crosses briefly into our here. That doesn't happen often. Before 2017, we had never seen an object from another star pass through our solar system. Now we've seen 3. That may not sound like much, but in cosmic terms it's a revolution. It tells us these objects are more common than we once believed, that the galaxy is more dynamic, more fluid. That material is constantly moving. Exchanged between systems like pollen on the wind. Some of that material may even carry the seeds of life. Comets are rich in organic compounds. They contain water, carbon, and other building blocks. If those same ingredients exist in interstellar comets, it could mean the chemistry of life is widespread, not confined to Earth or even to our Sun. This possibility excites scientists and dreamers alike, because if life's ingredients are scattered among the stars, then perhaps life itself is not rare. Perhaps it arises wherever the conditions are right. Perhaps the universe is not just habitable, but inhabited. 3I/ATLAS doesn't answer that question, but it moves us closer to asking it in better ways. It pushes us to build better telescopes, to scan the sky more carefully, to pay attention to the quiet, drifting things that might otherwise go unnoticed. It also encourages cooperation. The study of interstellar objects isn't limited to a single observatory or agency. It's a global effort. Amateur astronomers, academic researchers, space agencies and sky watchers all contributing what they can. That spirit of collaboration is part of what makes science beautiful. It reminds us that discovery is a shared human endeavour. And there's more. Studying interstellar objects helps us prepare for the future. Right now, we're observers, but one day we may be explorers. Missions like ESA's Comet interceptor are designed to sit in wait, ready to intercept the next fast-moving visitor. These missions could return samples, capture images, and analyze surfaces, helping us move from distant observation to direct interaction. It's a small step toward becoming an interstellar species. Before we can travel between the stars, we must understand them, and before we understand them, we must study what comes from them. Every object like 3I/ATLAS is a gift, a fleeting opportunity to learn, to wonder, and to prepare. Even philosophically, there's something profound in its passing. In a world often filled with noise and urgency, the quiet arc of a distant comet can remind us to slow down, to look up, to consider the long view, the cosmic view. Because the story of 3I/ATLAS isn't just about astronomy, it's about time. This object has likely been travelling for billions of years. It may have formed before our Sun, before our Earth, before life began on this planet. It has endured cosmic radiation, gravitational slingshots, and the deep cold of interstellar space, only to arrive here, now, while we are watching. That coincidence is staggering. What are the odds that a civilization capable of observation would exist in the brief window when this object passed by? And yet here we are, eyes pointed skyward, instruments tuned, hearts open to mystery. Maybe that's the real gift. Not just the data we collect, but the perspective we gain. The reminder that we are part of something vast, ancient, and beautiful. That the universe is still full of surprises. That the night sky holds more than stars. It holds stories. And 3I/ATLAS is one of them. A story that began in another system, that travelled through the dark for eons, that arrived silently with no announcement, and that now leaves behind not just a trail of dust but a sense of awe. So why does it matter? Because it reminds us to stay curious. Because it teaches us that even in silence there can be meaning. Because it proves that we are not alone, not in the sense of aliens or visitors, but in the deeper sense. We are not alone in time or in space. We are part of a shared galaxy, a shared story, a shared destiny. And every once in a while something comes along to remind us. A faint light in the sky, a trail of interstellar dust, a whisper from the stars, that's why it matters. There's also something poetic in the fact that these objects, though ancient and inanimate, become participants in our scientific journey. They drift unknowingly into the realm of human observation, allowing us to study them, debate their nature, and weave them into the narrative of exploration that has always defined us as a species. 3I/ATLAS also represents a moment of cosmic alignment, not just astronomically, but culturally. In an age when so much attention is focused inward, on screens and noise and endless speed, this quiet object invites us to pause, to step outside, to rediscover the sky, and to remember that we are still explorers at heart. Its journey is a gentle challenge to our sense of place. It reminds us that Earth is not an island, but part of a larger network of systems, stars, and motions. We are not isolated. We are orbiting, moving, travelling, and being visited within a galaxy that is itself alive with motion. And for the next generation of astronomers, 3I/ATLAS may become a defining memory. The comet they watched from their backyard, the name they read in headlines, the moment they decided to look upward, to learn more, to follow that spark of curiosity wherever it might lead. Every discovery begins with a question. Thank you so much for joining me on this cosmic journey. If you enjoyed drifting off to the mysteries of the universe, don't forget to gently tap the like button and subscribe to the Sleepy Cosmos for more soothing explorations through space. Sleep well, and I'll see you in the next video.